There are so many threats and vulnerabilities that we have to be aware of and protect our application against. Now, there is this organization called OWASP. It is a non-profit organization. And what they do every 3 years, they come up with the top 10 vulnerabilities and top 10 threats that we need to be, as developers, we need to be aware of them, and we need to do some protection, so to make sure that our application will not be subjected to these problems. So recently, the top 10 vulnerabilities has been updated in 2017, and you can see them here. What I want to do, I want to go through them very quickly, and some of them I will show you a demo what they mean, and we discuss quickly how we can prevent them. So the first one is called injection, and this is very common vulnerability. So what injection really means, you have some interpreter. So let's say you have a common example is called SQL injection. Nice demo here I found on the web. So what I have here, this is a very bad programming practice. So the user logs in providing a username and password in a form. They type in the username, they type in the password, and then as developers, many developers, they need to go to the database, check whether the username and password match what the user provided. So one way to do it is to use string concatenation. So I'll go ahead and do here select name from user, where username equal to the username that came from the form the user have entered, plus, and the password is equal to the password the user have supplied. Then I take this and execute this query, and if the username and password match, then the user will be allowed to log in. Let me run this and just do a normal login. So I'll go here admin 123, and the password is correct, so it allows me to go ahead. Let me redo it and do here admin 1234. Try to log in. It will not allow me to log in because it is invalid username and password. Okay? Now, but this application is very vulnerable to injection. Injection means the hacker will try to send some, instead of sending in this scenario, instead of sending the username and password, it will try to send some kind of code. I will type this one in the password field. So the password, when it comes, it will be concatenated with this. So password would be password equal -123, and then I close the dash. So that is a valid SQL. Then I'll say or this condition, 1 equal 1. 1 is always equal 1, which is true. So whatever password I type, it will be accepted. And the username is admin, and the password is the password that we discussed. And then basically I am in. So, this is an example of SQL injection. The idea here, let me just generalize this idea. The idea is I have an interpreter. In this case, the interpreter is the SQL engine. This SQL engine takes a string commands and execute these string commands. So what the hacker is trying to do is, if here I am opening the door to the hacker because I am concatenating the input coming from the user with my own legitimate command. So there is some legitimate code plus the hacker code, and I take the concatenates both and then submit it to the engine. The engine, it takes a string and executes it. So there are one way to overcome this is, first of all, if you are using let's say SQL Server, there is something called store procedure as an example. And what this store procedure does, it takes in parameters. So instead of doing concatenation, you pass parameters as if it is, store procedure is similar to a function. So it takes in parameters rather than doing concatenation. The other thing you can do is you can encode your input. What encoding means, it will replace some of the characters, like in this case, the space. What you do, you take your input, the user input, and you pass it through, let's say, a URL encoder. This is encode URL. It's just a function in JavaScript. And what it will do, it will make that password the user have entered harmless. It will replace the password, the string. It will replace the spaces with this %20. Now let me show you another example of this injection attack. It's even more serious example. There is an application, an app on GitHub called Node Goat. This application is a very vulnerable application. We can use it to understand these vulnerabilities. So let me show you an example vulnerability of injection. So injection is not limited to SQL injection. It could be also in JavaScript itself. So here is an example. I go to this contribution form. What I'll put here, instead of putting a value, I'll put an SQL code. Okay. In this case, what this code is doing, I'll say go to the process is a built-in object in Node.js. I'll say process.kill and then say process.id. This is kill the current process. So when I submit this, basically immediately my application is no longer available. It has been stopped. So this is an example of denial of service attack using injection. Injection is whenever you have some input from users and you take that input and you pass it through an interpreter. Interpreter means it takes a string and executes it. So in JavaScript, there is a very evil interpreter built in JavaScript, which is the eval function. In reality, most developers should be aware of this. So let me just show you this eval function. So if I go here and say eval, you see? So eval, it takes a string. It can be, let me try it as a string. And evaluates it. So this is an example of an interpreter. So an interpreter is some kind of engine, or some kind of, in this case, just a simple function that takes a string and evaluates that string. Okay? So SQL, for example, SQL database, it can be considered as an engine that takes a string and executes it. So whenever you have this kind of scenario where you build a string and supply it to some kind of function to execute, then you have a potential threat from injection. So let me show you what's going on here. So let me copy this one. And in here, I will put this very dangerous code here. So what this guy will do, it will kill this process. So what I'm expecting now is the second function should not execute. See here, it's just, the second function did not execute. The program terminates after the first statement. So what these poor developers of this app are doing in here, because remember, when I submit a form, this value will be a string. So they want to cast it to a number. So instead of using, let's say, parseInt or some other function to cast this to a number, they used eval. And they gave this string to an eval to basically convert it to a number. And then because they are using eval and take this input and put it through eval, what's happening is they are opening it to injection. So let me show you another small example how people can steal files and steal secrets using this simple injection. So let me take this code here. So what this code is trying to do, it's requiring the file system library, and then it's going to the current directory, okay? And then it's saying read the folders and the files in the current directory. Tell me what are the files and folders in the current directory. Okay, so if I copy this one and put it in here, I'm doing another type of injection. It's basically now stealing the data. So I'll do here submit, and you can see here it gave me back the files in that particular folder. And then in here I might see some folders that are more interesting. Like in my case, for example, I looked and there is this file here called config environment all. It might have some interesting data that as a hacker I might be interested in. So I'll go there, and through this window, this gives me the content of that file. So this is just to show you how dangerous injection could be. Because basically now I have a full JavaScript interpreter. I have a window of opportunity to submit any JavaScript, and I can basically manipulate the application. You can see I was able to kill the whole process and make the application offline. I'm able to discover what are the files and folder like within the application. I am asking even the content of some files and so on. So this is very, very, very dangerous. So the idea here, whenever you have an interpreter, whether an SQL interpreter or a regular expression interpreter, or let's say in our case an eval, you should never trust the user input, take it literally and put it through this interpreter engine. The second major kind of vulnerability, or a very common vulnerability in web application, is broken authentication. Broken authentication can be manifested in many scenarios. One simple scenario, you might have an application, especially in public computers that are shared by multiple users. Or even a user, they can close their browser, step out, and from their computer, somebody can open the application, and they can go back to the application, and the application will not ask them for a username and password. Because usually, if you have a session, remember last time when we talked about authentication, there is session-based authentication and there is a token-based authentication, if you remember. Okay? So the application will remain logged in for a certain period of time, typically 20 minutes or so, maybe even longer. So if somebody comes back to the same computer and opens the browser, within a period of time, they can have access to the application without the application asking them to log in again. So this is very dangerous. So how can we avoid this? That somebody can come and reuse the same browser and reopen the application, and the application is not asking them to log in again.
Maybe set a short timeout for the session.
Very good. One way is to make the sessions shorter period. Second, what else we can do here?
Maybe once the user finish the session in 10 minutes.
Unfortunately, we cannot do that. This is the problem. Because when you close the browser or you close the app or the tab, basically the server does not know.
If we are storing the session credentials
this is the problem. The problem is when you close the browser or navigate away to somewhere else, we basically cannot detect that. Yes. So the other way to do it is even for sensitive action within your application. Let's say you are in a banking application. Okay, the user managed to log in. They can see the accounts. But if they want to transfer, for example, you ask them to authenticate again.
Or maybe set up a plan for your.
Yes, or sometimes it's double factor authentication. You authenticate and they send you another code to validate that, to authorize that operation. So in here, sensitive actions within your application, you ask for re-authentication. So even if somebody managed to get it to the application after you leave it while the session is still on, if they try to do something sensitive or something of value, you ask them to authenticate again. Another example is session hijacking. You remember, if you have a session on the server will send you a cookie that has the session ID. If somebody has that cookie ID, they can steal your session. They can go back to the server with that cookie from another browser, and they can access the session instead of you. So, and this is typically happens if you do the initial login or the initial interaction with the server is in HTTP, using plain HTTP. Then somebody can intercept this communication, and they can see this cookie, and then they can use it in another browser to take over your session. Same thing even for access token. Remember last time we saw access token and ID tokens. Those tokens, if you don't use HTTPS to establish the interaction with the server, those could be intercepted along the way, and they can be stolen, and somebody can impersonate you in another machine. So in here, what's the way to avoid this? You use HTTPS. You have to use HTTPS. So even if the traffic is intercepted, the traffic will be encrypted, and they cannot see let's say the cookie or the access token that is returned by the server. Okay. Another scenario of broken authentication, you decide to manage username and password yourself, but when the users register, you store password as they are in the database without encrypting them or hashing them. So if the database is compromised, so the hacker will have access to the plain text passwords, and they can basically enjoy themselves, or even worse, publish them somewhere, and people can access your application with any username and password that is already published. So at least if you take the responsibility of registering users, you need to encrypt or at least hash the password before storing it in the database. So anything sensitive in the database, you should be very careful, and you should be hashing it or encrypting it before storing it. It could be personal information, credit card information, passwords. You should encrypt anything sensitive before storing it, because the database could be compromised, or somebody, even internal like a hacker or an insider, they could have a backup of the database. They can restore it somewhere, and they can access all this sensitive information. So any sensitive information should be encrypted. The other thing is brute force password guessing. You know this, there are so many database passwords from previous hackers. So there are millions of passwords. So you can do brute force. You can write simple program that iterate through these passwords and try to brute forcefully log into your application. So how can this be avoided? That's it. Thank you very much. Limit the login numbers. So after 3 trials, your account is locked. So whatever password you try, it will never let you in. So that's very simple. That's why you have this locking. Our accounts sometimes get locked to avoid this brute force. The other one is to have at least double factor authentication. So for example, in QNB or banking these days, whenever you log into your banking, online banking, even if your password, everything is correct, they send you a PIN and you have to enter it. Okay, so that's called double factor authentication. This avoids this brute force. So you have the account locking the account after a certain number of trials, and you have also the double factor authentication.
But even from the pin, you can brute force it, but I think they only always set time off for the pin validity, right?
Yes. Again, yes, very good. So there is the PIN validity, yes, that's a good point, and also the lock-in of the account after certain trials, certain number of trials. It is clear the broken authentication. These are various scenarios that could happen. Okay, sensitive data exposure. This is the third vulnerability, very common vulnerability. We just kind of discussed some of it. Anything sensitive, you should be very careful, whether it is in transit in the network, this data is transiting the network, you should transmit it through, in the context of the web, through HTTPS, not plain text HTTP. Also, when it is stored, either in files or database or logs, you should be very careful. Any sensitive information should be very carefully taken care of. Because don't forget, there is also the insider attacks. It's not only from the outside. So you could have somebody from IT, if they have access to the log or access to the database, they could misuse that information, such as credit card information or password information. So it should be very carefully, very carefully managed. And these days, you know, like we hear a lot of this stolen database with usernames and passwords and personal information, and this could be very damaging to the reputation of the organization and could be very costly. Not only this, I think we see a lot of emails these days, like websites are updating their privacy policies because there is now a very strong law just adopted recently in the European Union where there is very, very heavy fines for mismanaging personal information of users. So it is an obligation of the application owners to really properly manage personal information. This is straightforward. Any sensitive information your application is managing should take care of it, whether in transit or in storage, database or files or logs or any other place. Okay, so this is the third vulnerability, sensitive data exposure. So this is an example. For example, let's say it's good to log when there are errors. So somebody is trying to authorize a payment, and there is an error in the payment gateway. We are trying to use a gateway to authorize the payment, and the developer might store in the log the actual credit card numbers, for example, and then some insider attacker could access the logs and get this information that is in plain text. So this is a small example of sensitive data exposure. Another vulnerability that is recently has been added to the list of the top 10, which is called XML external entities. So this vulnerability we haven't seen, you might not be convinced with it because we have not seen XML. We have been using JSON, very straightforward using JavaScript. We can serialize and deserialize objects in JSON, but believe it or not, out there, XML is still heavily used in many, many applications. And there is one particular vulnerability in XML documents. In XML, what we have when I create a document, I can create a document definition. What a document definition has, it has the schema of the document. What are the properties I can have in this document? So in the schema of the document, there is a language called DTD, Data Type Definition Language. And in this DTD, what I can do, I can create what is known as an entity. And this entity could refer to some external resource. So let me show you this in concretely what it means. So here is an example. So here I create an entity foo and an entity bar. And this entity bar is basically referring to a file within my application. a file within my system. So if so here is my, so this little document that you see here on top, doc type, this is called the document definition. So I have a document that has two elements, a foo and a bar. Foo could be anything. You see any here is any data type. It could be a string, a number, or whatever. While bar is basically a pointer to another resource. In this case, a file that is reside in my database. Sorry, it is a file that resides in my system. So this is the definition. It's like a class, and this is an instance based on this definition. So here I have an element foo, and within it, I create an element bar. So when I say element bar, what it will do, it will go to this file and read its content and display it within the foo element. And basically, I'll get the content of that file as embedded within this foo element. Now, what happened here is in many applications, especially application to application, or in certain scenarios, an application submits an XML document. Like the user submits an XML document to your application. And basically what happens is there is a library that takes this document, this input document, and process it. So while processing that document, it will resolve this external entities references. So for example, this bar is referring to this file. So when this document is processed, it will go and read that file and provide the content. So a malicious user could embed external references to a sensitive files within your system. And when this file is processed, and the reply that goes back to the requester may include some sensitive data. Again, this is an input. The document itself is an input coming from the user. This input will be processed by an XML parser, and this XML parser will produce a reply. Okay. Another type of attack is that here I could refer to an external, to a file that is a really program. Let's say it could be even an external file. That this program is a random file generation. It's a program, so it's an infinite loop that basically keep generating some numbers. Okay, and this will never kind of come back. And this is another example of denial of service attack using this. So the server will be so busy trying to resolve this entity. So entity resolution or external entity, the idea here is that my definition, my type definition is referring to an external entity, and the XML parser will try to resolve that entity. So if that entity is a program, putting me in an infinite loop, I'll be waiting for that entity to resolve forever. And basically a lot of resources will be allocated to that task and reducing the availability of the server. So luckily, this might not be too convincing for us because we have not played with this kind of legacy technology, but it is still there and we need to be aware of it. Okay. Now, this has been kind of solved in many XML parsers. You need to apply patches. Most of XML parsers are now aware of this, and they have disabled entity resolution by default. So if you use an XML parser trying to process such a document, the entity resolution will not work. You have to explicitly, as developer, enable the entity resolution. And so, but if you happen to use before, according to my reading, before 2014, this was heavily discovered or heavily exploited in around 2014. So most of the XML parsers have been already patched to disable this entity resolution by default is disabled, and you have to enable it. But if you have some legacy application that is not patched, you are exposed to this type of attack. So just kind of be aware of it. Broken access control. And this is, by the way, very common. What we have here, sometimes you see a URL that has some parameters. What you do is those parameters, maybe the parameters is your student's ID, as an example. You might try to put another ID. In many cases, it will work because they don't check. They don't kind of consider that the user, either curious user or malicious user, will try to manipulate those parameters. So this is easy to fix. How can we fix this? Yeah. No, even here the user is already logged in, but they are trying to access something they are not authorized to do. So basically put this authorization. Make sure the user, whenever they ask for some, whenever they ask to access certain objects by ID, make sure they have access to that particular ID. And the URL, sometimes this is old stuff, but sometimes you might be asking, you might see in some old websites, you see here page and it gives the page name. So you might ask for different page names. So you might get some other page names and you might be lucky to get some, you put your hand onto some golden data from that website. So the idea here is, again, before you allow the user access to what they have requested, especially if the resource name, here is the resource, these are resource names. You need to be careful. If these resource names are exposed to the users, you are exposing yourself to such broken access control vulnerability. You need to check that the user really has access to these resources that they are requesting. That both on the client side and the server side. And remember, you could have done it on the client side, but they can bypass the client side. It's very easy to bypass the client side, and they still be caught up in the server side. Basically, whenever they request certain route, you do authorization. Make sure they have access. They have the right role. They have access to what they are asking for before you allow them to get there. But this is very common. You can try it in many applications. You will be surprised it's not validated. And it's easy to fix. Put the whenever the user tries to do anything and manipulate the URL and change the parameters in the URL or change the resource requested in the URL, make sure that you validate that they are authorized to do so. And there is the developers tend to fall into this trap called security by obscurity. They think that since the user is not seeing this URL, the users will not guess it, or they will not manipulate the URL to try to access some other parts. So it doesn't mean if the user does not see the URL on their web page, it doesn't mean they cannot access it. They can still guess it from the name. Especially, as developers, we try to make things meaningfully named. But that can be a double sword, where, for example, I have here a URL /users, I might say /admin, /manager, /instructor, and try to see what's out there. Even if this link is not available in my links in the menu, I can still try to guess them. So the only way here is to make sure every URL that you have in your website, you are verifying the authorization before allowing access to it.